Alright, so your Chapter 7 test is tomorrow. And it is going to be very similar to this packet. Okay, now, I said make sure like you're showing your work for these. Some of these there might not be much to show, that's fine. And I said unless otherwise noted, leave your answers as a fraction. Okay, and were some that were noted that it's going to be the same thing on your test. So leave them as a fraction. Okay, and then hopefully you read through your directions. Okay. All right. So for the first one, how many ways can she choose to redecorate? This is the fundamental counting principle. So you're going to multiply the 4 times the 3 times the 2 times the 3. Okay, that's how we get the 72. Now for number 2, I know this one was kind of tricky for us. So it says, how many different ways can a student choose and read 5 of them? Okay, the part that's important here is they're asking how many different ways they can read them. Are you going to be reading all of these at the exact same time? No, so this is a schedule. Anytime it's a schedule, the order is going to matter. Okay, now, I'm going to give you an example of how it would be different. If they were saying, oh, she's going to a library, how many different ways can she choose to check out 6 of 100 books, right? Then the order wouldn't matter because you're checking them all out at the same time. Okay, but if you're reading them in a certain order. So there's 2 ways you can do this. If order matters, you can use the permutation on your calculator, the 6p5, or you can think of it as she has 6 choices for the first one, 5 for the next, then 4, then 3, then 2, and multiplying together. That's how you get the 720. Okay, so whichever way you want to for those. All right, for 3, you have to find the probability a student is a boy, so you have to use this to figure out the total. So there are 4 boys, there are 6 girls, 10 total. Probability of a student of a boy is 4 out of 10, so you have to reduce that to 2/5. Okay, and then for number 4, a coin is flipped 4 times. What's the probability it will land on heads twice, then tails, then heads? So usually what I'll do is I'll write out. So heads twice, the probability that it lands on heads once is 1 out of 2. Heads twice is 1 out of 2. Then tails is 1 out of 2. And then heads is 1 out of 2. So you're just going to multiply those together to get 1/16. All right, the geometric probability. So the formulas that you will need to know for your test is area of a rectangle or square, length times width, area of a triangle, which is what? 1/2 times base times height, area of a circle, which is pi r squared. Okay, so I have that here if you guys need to write it down so you can study that, pi r squared. Okay, so to find the area of the shaded region, we have to take this whole rectangle and then subtract all of the non-shaded regions, which consist of 4 little triangles and 1 circle in the middle. So to find the area of each triangle, the base and the height, this is 1 and 1, so 1/2 times 1 times 1 is 1/2. So if each one of these is 1/2, what is their total area? 2. 1/2 plus 1/2 plus 1/2 plus 1/2 is 2. So we're going to take the total area here, which is an 8 by 4, right? This side when you add it together is 4. This side when you add it together is 8. Okay? And subtract 2. And then we also have to subtract the circle, which is pi r squared. The r is 1, so we're going to subtract pi. Okay? And then this is going to be a decimal. Don't round the decimal. Okay? So when you do that, you can do the 32 minus the 2 for the triangles minus the pi. So use your pi button. Okay, and then you're going to divide that by the total, which is 32, and that's how you get the 0.84 rounded. Okay, if you put 0.839, that is fine as well, because it didn't tell you what place. Okay, do you guys have questions on that one?
Why would you put like this 30 minus pi over 32?
I put it like that so it would be exact. So like the 32 minus 2 I can do in my head. So when I'm putting it in my calculator, I just do the 30 minus pi. Yep, so don't round until the end is the main thing for that one. All right, and then for 6, 2 coins and a number cube are tossed. What's the probability both coins show tails and the number cube shows a 2, 3, or 4? So the tails is 1/2 each time. The cube is 3 out of 6, which again is 1/2. So it is 1 out of 8. Okay, you could also reduce. So if you did 3 over 24, that reduces to 1 over 8. Now the next one, they ask you about the complement. You have a blue and a white number cube. We know that all numbers are equally likely. What's the probability that the sum is greater than 4? If the sum is greater than 4, there are going to be a lot of options. So instead of me listing out all of the sums that were greater than 4, I did the probability that the sum is not greater than 4 and listed those out. So remember, in your book, they do a really good job with a blue and a red number cube of listing out every single possibility. So I always start with the ones. So a 1 and a 1, a 1 and a 2, and a 1 and a 3. Those all have a sum that's not greater than 4. Then I go on to the 2s. So 2 and 1, 2 and 2, those have a sum that's not greater than 4. Then I go on to the 3s. 3 and 1 is the only one that's not greater than 4. There would be none with a 4, none with a 5, none with a 6. So there are 6 total options, okay, which means for the ones that have a sum that is greater than 4, it's 30 out of 36. And then that's going to reduce to 5, 6. And then the complement is always 1 minus that value, which will be 1 out of 6. Which if you did it from here, 6 out of 36 is also 1 out of 6. So you can choose which way you want to do that.
How do you get 30 out of 36?
So I knew that 6 of them that I found here did not have a sum that are greater than 4. And then because the total is 36, you just subtract it. And that would be quicker than listing out all the ones that are not. All right, 8 and 9, these can be kind of tricky. So again, a lot of the probability and the differences are in the language. So for 8, when they ask you what's the probability that a person is in this age group, given that he or she liked the movie, the given is what goes in the denominator. So given that he or she liked the movie, you're going to have to find the total number of people that liked the movie. Okay, so liked it, there were 26, that's your total. The top is going to be the people that are both 18 through 34 and liked it, which is 12. Okay, so if you accidentally put the 12 over 50, okay, it's not that because of the given. But if we go to 9, it says what's the probability that a person is in that age group and that he or she liked the movie. So if it says and, then you're going to put that number of who liked the movie in the age group over the total, which is 50. Okay, so to find the total, you can either add up the columns and add them together, or you can find the rows and then add them together, and you'll get 50. All right, questions for me in 8 or 9? Yeah. Yeah, so for 9, because it says that a person is in this age group and that they like the movie, you're going to choose the box where they both happen. So if they like the movie and they're in this age group, so 12, that's how you get the numerator. And then the denominator is going to be the total number of people. Because it's an and, you're going to find the total, and you can either do that by adding the columns. So I added them, put the totals here, and then added all of them together. This is the total number of people. Okay, and then for number 10, it says, what is the probability that a graduate chosen at random was in the band or had taken an art class? Okay, so if it's the or, that's where you add the two probabilities together and subtract the both. So the one that we did in our notes, we did one about manicure and a hairstyle. So if it was in the band, we're going to find the probability that they were in the band. So it says 89 were in the band. Okay, that's where the first one comes from. Okay, then in the next one, it says, the art one is that 45 took an art class. So that is the total. Okay, so the total of art is the 45 over 200. The both is where you have to calculate. So it says only 20 of the students who took an art class were not also in band. So you have to take the total of people in art, subtract the ones that are not in band, and you will get the ones who are in art and in band. And that's the overlap that you have to subtract. Okay, which will give you 109 over 200, which is the total. Okay, and then 109 divided by 200 is 0.55. All right, for 11A, it's asking you how many people prefer the elliptical. So you're just going to total the elliptical. 3 plus 44 is 47. And then for B, how many people were pulled altogether? That's 85. So again, I just added up the treadmill and the elliptical columns to get the total. Now, C has some special wording. So it says, what is the probability that a woman is selected who prefers the treadmill? Now, if this had said and, you would put it out of the total 85, but it doesn't say what's the probability that a person selected is a woman and they prefer the treadmill. It says what's the probability that a woman selected prefers the treadmill. So on the bottom is the total women, and then on the top is the treadmill and women. Okay, so the treadmill and women is 13. The total women is 57. Okay, so that can be one where the language might be a little more confusing. Okay, for 12, which of the following statements is true? It's B, that most of the women prefer the elliptical, and I just wrote out why these ones were false. It says more men were pulled than women. Well, if you count, there are 28 men, 58 women, so that's wrong. This one says most men prefer the elliptical. If you look at it, more men prefer the treadmill, and then this one says more people prefer the treadmill. Nope, 38 to 47, so not true. This is the only one that's true. All right, and then for 13, you have the passcode. So 3 letters, 3 digits. Letters can't be repeated. So there are 26 letters in the alphabet. You have to know that. And then, because they can't be repeated, times 25 times 24. But the digits can. You have to know there are 10 digits. And because they can be repeated, it's 10 times 10 times 10. If they couldn't, it would be 10 times what? 9. Times 9 times 8. Yep. All right. And then for 14A, if this is in parentheses, you can do this first. And remember, you do have a button on your calculator that does the factorial. So if you want to do 9 and then go to math over to probability, the factorial, okay, and then minus, and then I would put this in parentheses. So this is 3 factorial, okay, and then 6 factorial. So, what? Because I put minus, why didn't you tell me? Just got to do divide. And then it should do it right. Yay. Not yay. Is that what you guys got? Thank you. Alright, starting over. You can also cancel it out, which is how I told you in the first place, right? 9 times 8 times 7 times 6 factorial. this doesn't convince you to do it out, I don't know what though. Okay, so 9 times 8 times 7, and then 3 factorial is just 3 times 2. Gotta put it in parentheses. See how our calculators lied to us? Alright, we got it, finally. Yay! Alright, now this one might have been tricky. You cannot subtract that and make 3 factorial. Think of your order of operations. What comes first, multiplying or subtracting? Multiplying. So you're going to have to multiply before, okay? Now, wish me luck. Okay, so this is 8 factorial on top minus 5 factorial. And the bottom, remember, the 0 factorial is what? 1. Okay, it can't be 0. That will change it. So that's how you get the 40,200. Okay, that's what you would get on top. All right, 15, we actually went over one that was very similar to this yesterday. So you're trying to find the probability that the orange cube shows an odd number and the product is 15. So you have to do the probability of the odd number, okay, odd on orange, and that's going to be multiplied by the probability that the product equals 15, given that it's odd on orange. Sorry, I kind of just moved that in. So you guys are good at the odd part, right? 1 out of 2. But now, for this one, if orange is odd, it's either a 1, a 3, or a 5, okay? If you want the product to be 15, then if it's 3, it has to be 5, okay? And if it's a 5, it has to be 3. So that's 2 out of 18 choices. Do you guys remember why there's 18 choices? Because for each one, how many choices do you have? 6. So this could be a 1-1, a 1-2, a 1-3, a 1-4, a 1-5, a 1-6. So there are 6 options there, 6 options here, and 6 options for that one. Okay. All right, and then this one, you have a standard deck of cards. So you have to know that there are 52 cards in a deck. It says, what's the probability you draw a spade? How many are there of each suit? 13. Okay, and then for the second one, a red jack. How many red jacks are there?
1.
No. 2. Hearts and diamonds. Okay, but if you don't replace it, what happens to the number?
It goes down 1.
It goes down. So if you don't replace it, it goes to 51. If you do replace it, it goes to 52.